Okay, math fans, if it's Saturday night, March 21, then you're live, and this is how to find an inverse function. Um, Pretty straightforward. It's not really asking a lot of the more complex questions that it could ask about this, like can you prove that there is an inverse and that the inverse really is a function? Those kind of questions aren't being asked. It's just saying, hey, find the inverse. There's a simple process to this, and we're going to run through it really quick. First thing we're going to do is we're going to convert this thing here, this f of x, back to the old notation that we used for many years, the y equals 2x minus 3 x plus 1. I'm going to have a lot of steps, so I might kind of zigzag back and forth. Bear with me. Step 2 is anywhere I see a y, I'm going to write an x. Anywhere I see an x, I write a y. I'm just swapping those out. So now I'm going to have x equals 2y minus 3 y plus 1. Okay? Now we've basically set the stage, and what we want to do is we want to basically solve this equation for y. In other words, we want to go through whatever processes of equation solving, adding things, dividing things, multiplying things, both sides, until we get a y on one side all by itself, and everything on the other side is numbers and maybe an x or two. It's all good. So here we go. The one thing that makes this problem maybe a little more complex than others is that we do have two y's on the right side, and somehow we need to get those on the same side. We need to get them out of this weird relationship of division, and hopefully we can, if we get them both on one side, maybe we can find a way to factor out a y so that it's a single y, and then go from there. And that's exactly the process we're going to use. First thing I'm going to do is I'm going to multiply both sides by this y plus 1. So we're going to have x times y plus 1 is equal to 2y minus 3. Okay? I'm going to go ahead and distribute. I've got xy plus x 2y minus 3. Now I want to get these y's together. I want to get this x out of the way. So this x is going over here. This 2y is coming over here. Minus 2y equals, I'm going to subtract the x over here, negative x minus 3. Okay, so there were two steps being done here, subtracting the 2y from both sides, subtracting the x from both sides. Essentially these two terms just swapped places and changed signs. You can think of it that way. Okay, at this point I'm going to factor out a y over here, so now I'm down to a single y. I don't care how many x's I have. I need a single y on the left side of the equation. So this becomes y x minus 2 equals negative x minus 3. And at this point we're pretty much ready to take it home. We can basically divide both sides by x minus 2, isolating the y, negative x minus 3, x minus 2. Finally, we want to put this back into the original f of x notation, but we don't want to call it f of x. We already have an f of x. We want an f negative 1, because remember, when we raise something to the negative 1 power, we get the inverse, right? And we are trying to find the inverse function. So the inverse of f of x is equal to negative x minus 3 divided by x minus 2. Okay? That's all there is to it. We just found the inverse of this function. Didn't ask us to determine whether it was truly a function or not when we found the inverse. It just said find the inverse. This is the process. That's what it's looking for.